Okay, so I would just want to pick up this discussion on the primal and dual problem. So this was the primal problem. I showed it to you, the transportation problem, where you're shipping goods from origins, 3 origins to 4 destinations, and you want to minimize the shipping cost. So your primal problem is essentially minimize the z value such that where z is c times x, okay, and ax is greater than or equal to b, and then we already knew the values of x is my decision variables, and then a is the matrix that defines my constraints equations left-hand side, and then I have b that defines the constraints equations right-hand side, and I want ax to be greater than or equal to b. Now, if I want to write the dual problem for this problem, it will be so a couple of things that change is that this minimization becomes the maximization. And then I want to be, the constraint would be, and the new decision variable, the new optimization function is B transpose W. So quantity that I want to maximize is Y B transpose W, such that A transpose W less than or equal to CT, where W is my new decision variables, and I will end up with 7 different decision variables. Okay, I'll end up with 7 different decision variables, and I can, because I know C, I know A, and I know B already, I can write B transpose, A transpose, and C transpose, and I can completely come up with a dual problem. Okay, and remember, the dual problem will have decision variables equal to the number of constraints that I had in my primal problem. So number of DVs in dual problem, in this case, will be 7. So 7 decision variables. And then number of constraints in the dual problem will be 12 constraints. 12 different constraints I will have. Okay. So that's basically how I can write the dual problem. Now, I posted a video online on your Canvas page that basically takes this problem and transposes this into Excel. Okay, so what I want to do is, I asked you to do this, and did anybody get a chance to do this? Did anybody write the dual problem? Did anybody write the dual problem that we have here? Okay, so I want to write that problem, and it looks like you guys didn't get a chance to write this. So what I'll do is, I'll go ahead and try to write that dual problem on this sheet, and this is the parameter that I'm going to follow. So I'm going to maximize my Y, the new decision variable, B transpose W. Remember, my B matrix, a B transpose, and B transpose will be the constraints right-hand side. And remember, my B was my B value was negative 1200, negative 1000, negative 800, 1100, 400, 750, and 750. Remember, these were my B values, the matrix B. And then I can write B transpose would be negative 1200, negative 1000, negative 800, 1100, 400, 750, and 750. And W is going to be a column vector of all my decision variables. And let's call these decision variables W1, W2, W3, W4, W5, W6, and W7. And I'm just calling them W's, and I'll interpret them in a second for you. Okay, so I'm trying to maximize that. And then the next thing I want to do is I want to write my constraints. And remember, my A matrix A is this big matrix, and I want to transpose this matrix because such that my constraints are A transpose W less than or equal to C transpose. Okay, so my C transpose is simple enough. My C transpose is simple enough because I know C is this value right here. These used to be the coefficients of my decision variable in my original optimization function. So my C transpose, and because it's a maximization problem, my C transpose will be 12 of these, and my C transpose will be starting with 35, and then 30, and 40, and 32, 37, 40, 42, 25, 40, 15, 20, and 28. And you guys see where I'm getting this from? I'm transposing my original C matrix. If you recall the C, so I take this C and I transpose it, okay? And I got this. And then obviously my W's are what they are. So my W's are A transpose W. So W1, W2, W3, W4, W5, W6, and W7. Okay. So what's the size of this W? The size of this W is essentially 7 rows and 1 column. Okay. And the size of this is 12 rows and 1 column. And my A transpose, remember my A matrix? Remember this, my A matrix? What's the size of this? It's 12 row, it's 4, 5, 6, 7 rows and 12 columns, right? So it's got 7 cross 12 matrix before. It used to be 7 cross, A matrix used to be 7 cross 12. When I transpose it, it becomes 12 cross 7. Okay, it becomes 12 cross 7, and I can multiply that 12 cross 7 matrix with 7 cross 1 matrix. So these sort of cancel out, you can think of it, and I end up with a 12 cross 1 matrix, or a set of equations. So I want to write my A transpose now, and my A transpose will be essentially the transpose of this matrix. Right? So I'm going to write that down, the transpose of this matrix. Hopefully all of you can see it. This is going to be sort of big one. So I'm going to write 12 cross 7. So I want to write 12 rows and 7 columns. All right, 12 rows and 7 columns. And what do my 12 rows look like? My 12 rows will look like the transpose of this matrix. So I'm going to write my first row, which is going to be the transpose of this. Okay, so this becomes my column. Or you can think of this as this column becomes my row. So however you want to write it. So maybe I'll write this column into my row first. Okay, so -1, 0, 0, 1, 0, 0, 0. Okay, so that's basically what it is. So I'm gonna transpose it. So -1, 0, 0, 1, 0, 0, 0. So that's my 7 elements here. And then my second one will be -1, 0, 0, 0, 1, 0, 0. Okay, so I'm transposing these individual columns as my rows, and as I'm writing out, I know my writings. So then last one would be -1, 0, 0, 0, 0, 4 zeros, and then a 1, and then another 0. And then the last one, my 4th row, it'll be -1, and then 1, 2, 3, 4, 5 zeros, and then another one. Okay, so I'm transposing this A matrix that I had before, and I got my A transpose. And then I can do the same thing for the next rows. It's basically 0, -1, 0, 1, 0, 0, 0. And similarly, you can write it as 0, -1. Oh, something seems off here. No, actually, that's correct. 0, -1, 0, 0, 1, 0, 0. And then the last, and the next one would be 0, -1. And then 0, 0, 0, 1, 0. And then 0, -1, 0, 0, 0, 0, 1. Okay, I'm not doing anything fancy. I'm just basically taking my columns and writing them out as rows. Okay, and then the last one, the last set of rows really. I got 4 more to go. So I'm going to go 0, 0, -1. So I'm going to write this one, 0, 0, -1, and then 1, and then 0, 0, 0, and 0, 0, -1, 0, 1, 0, 0, 0, 0, -1, 0, 0, 1, 0, 0, 0, -1, 0, 0, 0, 1. So this is basically, I'm able to write my 12 cross 7 matrix. And then when I multiply this, I'll end up with -W1. So if I want to actually write down what these constraints would look like, so I've written my my new optimization problem, right? I've got maximize Y such that -1200 minus 1000 minus 800 W3 plus 1100 W4 plus 400 W5 plus 750 W6 plus 750 W7. Right? And then this will become -W1 plus W4. -W1 plus W4, this constraint. So I can write the first constraint will be -W1 plus W4 has to be less than or equal to 35. Okay, so this is my first constraint equation. I can write the next one, -W1 plus positive W5 should be less than or equal to 30. Okay, so that gives me my second equation, and so on and so forth. That makes sense? And I can write more, right? So let me write all the W1s, and then I can make the point that I need to make. So -W1 plus W6 is less than or equal to 40. And -W1 plus W7 less than or equal to 32. Okay, so this is my 4 constraint equation. And in fact, you guys know that there won't be just 4 equations. There will actually be 12 different equations like that. Right? Okay, so I want to take a little pause here and ask you, does all of this make sense? Could you do this on your own if you were comfortable with matrix algebra, right? So you need to obviously be comfortable with a little bit matrix algebra, matrix multiplication, and so forth. But does this all make sense? So it looks like most of you got this correct here, and you were able to write down these equations as, and I'm going to just take your product, or your work product. So for example, minus W2. So now all of these coefficients will be, for the second set of equations, will be minus W2 plus W4 less than or equal to 37, minus W2 plus W5 less than or equal to 40, minus W2 plus W6 less than or equal to 42, and minus W2 plus W7 less than or equal to 25. So this gives me number 5, number 6, number 7, and number 8. You all see this? Okay, so I got 8 equations, and then the last set is essentially minus W3 plus W4 less than or equal to 40, minus W3 plus W5 less than or equal to 15, minus W3 plus W6 less than or equal to 20, minus W3 plus W7 less than or equal to 28. Okay, so you got these values here. So now the question is, so you got all of these 12 equations. If you 9, 10, 11, and 12. So if you take these are your 12 equations, 12 constraint equations. So if you take these 12 constraint equations, right, what do we mean by these constraint equations? And what is this? If you look at the primal problem, this is how we defined it. We said, I want to minimize the cost of shipping stuff from these warehouses to these destinations such that, okay, given the constraints on how much stuff each producers can produce or each location can produce versus how much stuff each of these destinations actually need. Okay, so that was the interpretation, that was the problem given to us. Now, what could possibly be the interpretation of this? Now, hear me out. I'm going to describe an interpretation, and that's the interpretation of my dual problem, which is I want to maximize my Y, which is my profit. I want to maximize my profit. And how do I want to do that? I want to buy the quantities. I want to buy my quantities of stuff at S1, S2, and S3. So I want to pay some money to somebody to buy the stuff here. Okay. And I want to sell that same stuff over at these destinations. Okay. So I'm a different entity now. Okay. So I'm not the same entity that was interested in my primal problem. I'm a different entity solving a different problem, but a related problem. Okay. And that's a very interesting interpretation. So the entity that is interested in the dual problem is trying to buy the stuff at these 3 locations, okay, and sell the stuff at these 4 locations. Buy the stuff at origins, sell the stuff at destination, okay? And their decision variables are, what price should I pay at the purchase price at these locations? What should be my purchase price at these locations? And what should be my selling price or sale price at these 4 destinations? So what this means is W1, W2, and W3 in this problem are my purchase prices. Okay. And then these 4, W4, W5, W6, and W7 are my sale prices, are sale prices for that entity. And they want to maximize the profit. So, and then we know how much quantity they can buy and sell, right? They can only buy and they can only sell 1,100. They can sell 1,100 quantities as at destination 1, 400 at destination 2, 750 at destination 3, and 750 at destination 4. And they can purchase, they purchase 1,200 at destination 1, origin 1, 1,000 at origin 2, and 800 at origin 3. And they want to maximize the profit. So that means if these are their unit prices, so I can say unit purchase prices, right? These are my unit prices for purchasing and selling. What does 1 unit cost? So if I want to maximize my profit will be my revenue minus the cost of purchase. My revenue at destination 1 will be 1,100 times W4. My revenue at second origin or second destination will be 400 times W5. My revenue at third destination would be 750 times W6. And at fourth will be 750 times W7. So add those up and I get all my revenue. And then I have to subtract the cost, which is negative 1,200 times W1, negative 1,000 times W2, and negative 800 times W3. So if you kind of combine this, if you actually solve this matrix, you end up with one equation that describes your objective function. Okay? And that's your profit as that entity. How much profit can you make? And you want to maximize that profit. And so what do the constraint mean? This is the next one. What do the constraint mean? Constraint means, the thing about constraint is that negative W1 plus W4, or you can write that as essentially it's W4 minus W1, right? And I want that to be less than or equal to 35. So I'm rewriting the first constraint. W4 is positive minus W1 is less than or equal to 35. What does that constraint mean? See, if I buy for less amount here and sell for as much as I can over there, right? I will make more money. So I want to maximize that difference. But I'm subject to one particular constraint. That constraint for me is that my price difference between what I pay for the stuff here versus what I pay for over there, it cannot exceed 35. So that's what the constraint means, right? W4 minus W1 less than or equal to 35. W4 minus W1 is less than or equal to 35. What does that constraint mean? That constraint means that the price that I'm selling for at my first destination and the purchase price at the first destination, or purchase price of the first origin, excuse me. Okay, so what does this constraint mean? W4 minus W1 has to be less than or equal to 35. Obviously, I want to buy for the lowest price possible and sell for the highest price possible, but I'm constrained by the fact that my W4 minus W1, that means the differential between the price that I charge at the first destination minus the price that I pay at the first origin, has to be less than or equal to 35. Why? Can you think of why is that constraint making sense? Obviously, we derived it, it's correct, because we derived it based on writing out the dual problem. So the constraint obviously is in fact correct. My question to you is, does that constraint make sense to you? Let's take this by an example. Okay, let's think about these constraints with an example. So we know that the purchase price at each of these origins are W1, W2, and W3. And then the sale price at these destinations are W4, W5, W6, and W7. Okay. So now let's take any of these individual constraints, and let's take the first one, W4. Let's take this one. W4 minus W1 has to be less than 35. So W4 is right here. W1 is right here. It's the price that you pay at origin 1 is W1. The price that you sell for at first destination is W4. And I'm saying W4 minus W1 has to be less than or equal to 35. Okay. Now think about what's 35. Ooh. It's the shipping cost between those two pairs. It's the shipping cost between those two pairs. Why can't your price differential be more than the shipping cost? No, you won't lose money. If you could charge more money for it, that's great. The problem is, if you start charging a price differential that's higher than the shipping cost, nobody will sell you stuff here and nobody will buy your stuff here. That's the constraint. If you start charging a price differential, if you sell for more money here and buy for less money over here, and if that differential is less than 35, or sorry, if that differential is more than 35, whoever is selling you stuff here and whoever is buying from you over here, they're going to say, to heck with you. I'm just going to add the shipping cost. I'm just going to pay, whoever is buying stuff here is just going to pay the shipping cost to these guys and just get the stuff. So that's why you can't be too greedy in the dual problem. You want to maximize your profit? Yes. You want to maximize your profit according to this equation. But you have to be mindful of constraint is that your price differential cannot be more than, cannot exceed the shipping cost on that origin destination pair. Because if it does, nobody will have any incentive to sell to you. And nobody will buy from you over here. Whoever needs this stuff here, they'll say, hey, to heck with you. I'm just going to pay with the shipping. I'm going to just pay the shipping, and whatever is the purchase cost here, I'll pay and add the shipping, and I'll get my stuff here. And that's what all of those 12 constraints are about. So if you pick out any random constraint, like for example, if I pick out this one, W6 minus W3, so positive W6 minus W3 has to be less than 20. That means W6 is right here, W3 is right here, and then you could look at W6 minus W3 cannot exceed 20. Okay, and that's the interpretation. Okay, and you could sort of make sense for all 12 of these constraints, and that's what they mean. Questions? So it's not necessarily about losing money. It's just that not having that opportunity to actually make that transaction. So if your price differential is too large, exceeds shipping cost, people, whoever is buying and selling from you, are not going to do business with you. So you have to maximize your profit subject to the constraint that you have to keep the price differential lower than or equal to the shipping cost. That's been advertised here. Okay. So I'm going to stop here now. At least I'm going to pause the recording. So please go ahead and watch that Excel video online on your Canvas page, how to solve this transportation problem and the corresponding dual problem using Microsoft Excel and Solver. And you will notice that the answer to both problems is the exact same, $84,000. Okay, so please make sure that you take a look at that solution. It's going to come in handy to set this up for the lab tomorrow. Okay, questions? So one thing that, if you want to work on an additional problem for this, so there is one more. So we've done 2 problems right now, but there is one more that you could potentially solve or at least review. I'm not going to go over that, but if you start, let me go ahead and show your Canvas page here. So if you go to your 528 page, and so one thing that I've done is that under your syllabus, I made a video available on matrix algebra. This is something that you might want to watch. So that's one thing that you should definitely do. Okay, so how do you multiply matrices? How do matrices work? So I think this is going to be very helpful. Just some simple stuff. And I know a lot of you would already remember this, but it'll be a good thing if you haven't done it actually. So that's one thing. I posted that with the syllabus, matrix algebra. And then, so that's almost like a prerequisite material here. So that's why I posted that with the syllabus. And then the next thing I've done is there is a PDF file called Primal Dual Example Interpretation. So you can look at that. And you don't have to go through the whole thing, but you start at 4.3. So you start here. Okay, small example to illustrate between primal and dual linear problems. And you keep reading. And you just have to read up until duality theory, right above this. So you don't have to go through all the difficult mathematics that start. So just basically section 4.3. So just you have to read the section 4.3 of this. Okay, so I think that will give you one more perspective on how to write the primal and dual problem. So you should be able to set this problem up in the matrix form and be able to write this dual problem. So that will be another good practice for you. Okay, so I'm going to go ahead and stop sharing and stop my video as well.